Welcome friends, I'm Dharma. I welcome you all in my channel Chemistry and History of Molecules. So today we will discuss about the oxidation mechanism, mainly primary, secondary, tertiary alcohol. Previous video I have explained about the basic concept for ethanol oxidation, how this aldehyde as an intermediate oxidation state is prepared. Okay, so let's discuss about the mechanism. So today's discussion will mainly cover about the mechanism of oxidation of primary, secondary as well as tertiary, fate of chromium oxide reagent and the support for the mechanism. Okay, so let's start. So what happens? This alcohol first, for this reason actually you can see three types of oxidizing agent would be used. For example, dichromate, chromate or chromium trioxide. I have considered about the simplest example, chromium trioxide, because all the ultimate reagent are ultimately same, because all in case chromium is in +6 oxidation state and it ultimately produces +3, this reduced chromium green species. And what happens, for example, if we see this chromium 3 actually looks like this. Okay, so this chromium is attached to 3 oxygen. And if you consider this chromate or dichromate, they are similar. Their chromium is attached to 4 oxygen, and that is this, and you know this is chromium is 2-. So ultimately, all the oxygen are these oxygen has 2 lone pair, and this minus are 3, and all the chromium is in +6 oxidation state. So from this thing, you can consider that this chromium is attached to 3 highly electronegative oxygen atom. So oxygen should be delta minus and chromium should be delta plus. So this chromium is Lewis acid. Okay, some molecule having electron richness or electron pair can attack this chromium. For example, it could be HOH means water, it could be alcohol. And this attack means, for example, if we take this alcohol, so this attack is happening because of this Lewis acid, and in this way reaction starts. So what it produces? It produces this O. So if it attacks, it will open. So CrO, and after this first it will be, okay, let me draw clearly, R C double bond O, and you can see from this that this oxygen is right now plus. So it will prefer to leave this proton, and ultimately this will be a chromate ester derivative. And in every case, for case of primary, secondary and tertiary, this is a common step. After that, that reaction changes. Now question, how acid plays role? For example, if acid is this, then this should be delta minus, this should be delta plus. So acid is coordinated with this oxygen. Means, for example, this or this, any, I should write in case of this one. So this, and in this way the electron deficiency of chromium plus, because you can see the addition of carbonyl means aldol condensation or addition reaction to carbonyl influence of acid, similar concept. Means this oxygen is protonated, electron deficiency of this center electron deficiency increases, so nucleophile can attack, acid mediated activation type, carbonyl type reaction. So fine. Now let's discuss if it is primary alcohol. So if it is primary alcohol, then it should be CH, and ultimate product is aldehyde. So one hydrogen is left. That's why I not changed. So what happens? So here you can see till now chromium is in this is not +4, this is +6. Here it is also +6. So what happens? The water molecule in the reaction, okay, so they abstract this proton, this lone pair comes here, this goes here, this. So ultimately what happens? Right now after that this produces RCHO1 plus this chromium, double bond with this oxygen, single bond with this, another single bond with this. Okay. So right now you can see what is the oxidation state of this chromium. This is 4. But we have observed that chromium ultimately produces chromium 3, not 4. Okay, I'll explain the chromium part little later. So this is the case of aldehyde. So this is actually oxidized and this is reduced. Chromium is reduced. Fine. Okay. So what happens? Instead of that, if we take a secondary alcohol, what happens? So this H should be replaced by another R or R prime if it is secondary alcohol. Then what will be the product? Similar like that, it will be a ketone. R C double bond O R prime. Fine. But there is some problem because the first step you can see this nucleophilic attack on the chromium center. So if the bulkness attached to this oxygen means if it's a secondary alcohol, bulkness is more, so the attack is relatively less. So from that point of view, you can think that the attack will be little bit hampered. But this is not the RD step. RD step is this abstraction of proton by the water molecule. This is common, general. In some exceptional case, if this is too much bulky, then this could be. But don't consider for common example. This is the first step, acid-base reaction, Lewis acid-Lewis-base reaction, nucleophilic attack. This is the RD step. Second point, if it is a R group, so see, previously 2 hydrogen was available to abstraction, right now 1, so statistically difficult. Second, if you consider the electron deficiency of this carbon, because electron deficiency on this carbon will guide the positive charge density or acidity of this proton. So definitely, since this is the RD state, means this proton abstraction, so that will be affected. That's why secondary alcohol oxidation is little slower compared to the primary alcohol. Fine. But what about the tertiary alcohol? For example, if we take tertiary alcohol, then this hydrogen is replaced by another R. So this water attack is not possible. So tertiary alcohol doesn't follow this pathway, and under such condition, this could not be oxidized. It needs drastic condition. Drastic condition. How I will explain. So let's draw that tertiary alcohol part. This is chromium, this is oxygen, this is O minus, this is double bond, this is O. For example, let's take this R prime, R double prime, like this one. So this is no hydrogen. So how it could be oxidized? As I told that normal this condition it doesn't go oxidation, but more drastic condition it happens. How this happened? I do not have any support for this, but I have my personal logical explanation. What? See, the step is that this bond will break. Means initially it will happen because of, but actually if it is hydrogen, then this bond will break and this lone pair will be withdrawn by chromium. So similarly, what can happen? This water molecule or that can attack here. One, then it can push and it can go, but normal condition it will not happen. Second, another possibility such that this bond will break. After that, this will attack because it will be a carbocation and water will attack here. So in both way could be possible, but actually tertiary alcohol normally don't undergo oxidation. But when it undergo oxidation, drastic condition, fragmentation occurs. What do I mean fragmentation? Means this compound is broken. For example, you can see after this reaction, any one of R could be broken. Okay. And in reality, one example is found that if this reaction is that much sluggish, so we can expect that we can isolate the intermediate, and actually this is possible. What happened in case of this tertiary butyl, means this is a tertiary butyl chromate ester, diester. This is isolated. So this supports this fact of mechanism. And another thing, as I told, okay, I make one mistake here. But in every case, I have showed this O minus, but actually this O minus will not be. It will be converted to OH. Why? Because the medium is acidic. Fine. So it should be this. And in case of tertiary alcohol, another thing happens. What happens? This OH means more drastic condition, as I told needed. So what happens? This OH this OH is protonated because more stronger acid condition. So first it protonates and second it eliminates. And after that the electron deficiency of this chromium center further enhances. Okay, you may think that okay, it eliminates, but water addition elimination is a reversible reaction. Possible. So it may attack here, possible, but it doesn't mean that the electron deficiency of this chromium center is compromised. No, it is enhanced because of this as addition of acid. Additionally, you can think when there is a acid, there are oxygen lone pair, so they can bond. So giving lone pair electron density of oxygen to someone else means it will withdraw more electron density from the chromium center. So in this way, this center will be electron deficient. As it electron deficient, so it will prefer to take electron from this oxygen. Another positive charge density on this carbonyl carbon increases. So what is that? So the transition state actually involves, means this, if you draw this transition state, this is the bond that is getting broken, and for example this is the bond, this H actually broken, and for example let's consider one oxygen here, this and this. Okay, fine, I have written just this thing, and here, sorry, this should be one oxygen. So this bond, these dotted bonds are broken during the transition state. So in this should not be 4, this is 6. So at this situation, sorry, this should also be 6. So at this situation, see, the bond is breaking, and another thing, this carbon is, this is transition state sign. So this carbon is little plus charge, means like this, and this chromium is, in this way chromium is getting charged, this carbon is plus charge, carbocation. So it is expected, since it's a charged species, some other reagent could stabilize this charge center. Okay, let's discuss that. Let's look at this example. So what happens in this case if we consider this benzylic alcohol oxidation under the similar condition to produce this corresponding aldehyde derivative. So what is observed? Yes, this. So what happens? This proton is abstracted. Oxidation means withdrawal of proton. Another thing, our basic chemistry concept we know, reduction means the attachment of hydrogen, and oxidation means detachment of hydrogen. You can see one hydrogen from here, and this is eliminated to produce this. So this is in this way there is an oxidation process, removal of hydrogen. So this hydrogen will remove and produce. Now, as I told, this transition state is carbocation, so it is expected that electron-rich substituent, or which can stabilize the positive charge in the transition state, will improve the rate or contribute the rate or enhance the reaction rate, and this is obtained by this example. If this X is hydrogen, means the model, let's consider the rate is 1, relative rate. So, but when this is OMe, this para-methoxy, so this has a lone pair, and this lone pair could stabilize the positive charge developed in this position through the resonance, then the rate enhances. Interestingly, when it is NO2, means it's an electron withdrawing group, so it will not help to stabilize, the reaction rate decreases. So this factor suggests that this reaction is following through the positive charge or positive charge generation and this carbon. Okay, fine. And let's discuss about the final part of this question, that is the fate of chromium. What happens? Actually, first you can see chromium 3, means chromium 3 is reduced, chromium 6 is reduced to chromium 3. So chromium 6 is reduced to chromium 3. And alcohol is oxidized. I am not writing that. Second step, what happens? This chromium 3 and chromium 6 further reacts to, here it is, but this alcohol, this is a 2 electron reduction. So this chromium 3 is a 2 electron reduced because this alcohol is oxidized to unit electron. Okay, so chromium 6 should not be chromium 3 directly, and that is the twist of this place, that here 3 electron reduction, chromium 6 to chromium 3, but this process is 2 electron reduction. So how this reaction is happening? So the thing is that first chromium 6 is reduced to chromium 4. After that, this chromium 4 plus chromium 6, they both react. Chromium 4 plus chromium 6 react. This is called comproportionation reaction. Let me write this part here. Comproportionation reaction. Okay, means different oxidation state is converted to different called reacted and produce a final single oxidation state, and this is chromium 5. Now this chromium 5 is the main responsible factor, as this chromium 5 reacts alcohol, means for example RORCH2OH, and produces RCHO plus chromium 3. Because this is a 2 electron oxidation, 2 electron reduction, you can see this chromium taking 2 electron is reduced and alcohol is getting oxidized. So from 3 to 2 electron reduction, it will be chromium 3. So in this way reaction happens. Let me summarize it. First step, chromium 6 plus alcohol equal to chromium 4 plus carbonyl, oxidized aldehyde. So chromium 6 to chromium 4, then chromium 4 and chromium 6 reacts to chromium 5 intermediate oxidation state, then chromium 5 reacts further alcohol to chromium 3. So in this way it is proposed that this reaction follows in this way to finally produce this product. Okay, so I believe you have understood all the processes regarding the oxidation of alcohol using this chromium reagent. It's a very basic thing to be understood, and if this video is helpful for you, please give a like and share this video among your friends so that many people could be benefited. And another thing, I always try to give my best to make this video, and I expect that if it is helpful for you, you please support me by sharing this video among your friends and telling other people that I am teaching this, so such that they can read and my channel grows well. And finally, subscribe my channel Chemistry, the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload, and see you in my next video.